Okay. Hello. This is going to be well, it's not going to be a quick video, but I am going to try and guide you through the rendering processes, how we create materials, how we do all this, how the rendering works, and all that sort of stuff. As best as I can. Don't know if this is going to turn out great. However, this is going to be work. I'm going to try and do my best here. Okay, I'm just going to get rid of these notes that have been added to the file. And let's start out by just going inside here, and I'm going to get rid of the note here again. So normally we like to clean these up. So I'm going to move that out of the way. What you've got here is you have a output from directly from the DOP node. You can do that because it has this object merge here. But we don't tend to like to do that because we get a few different issues. Sometimes it's not recommended basically. So I'm going to use a DOP import fields for this because if I open it up and I dive inside, we're going to see it actually just uses the DOP import node instead. But I like the DOP import fields a little bit better because I can actually drag and drop the DOP node in, and then I can actually put in the name of it. Exactly. I'm going to say add one, and I'm going to say geometry. I could, however, instead just say particles, and it's going to auto fill for me. We go in here, we're going to see that we're going to get basically the same thing. We're just going to get a few extra attributes that are very handy when simulating basically. One thing I'm also going to do is I'd like to add some noise. This is just a personal preference. I've already gone through this file completely, but I would like to add a bit of noise to this. Currently, there isn't a massive amount of noise, and you're scattering over time. That's fine. I would like to add a bit of noise to this in itself. So we've got this sort of AA noise and this absolute one. I'd like to make another one. So what I'm going to do here is I'm going to create a turbulent noise. Actually, I'm going to create a cell noise. Let me think. A Voronoi. There we go, Voronoi. That's the one I want. And I'm going to plug in the position into here. And if I plug in the distance here, we're going to see something like this. I'm going to increase the frequency. And it doesn't look like much for now. And I'll actually show this in a better view. I'm going to put down a grid. Also, your particles, the scale of this is good. So you've got the scale coming down to about 1.6. So that's about the height of a human. These statues tend to be 4 to 5 times that, but that's fine. We don't need to worry about it. I'm also going to hide other objects, and I'm going to disable the lights for now. So we're getting something in here. I'm going to increase this to about 2000, both sides. And we'll see we're going to get some. Okay, I'm going to make it go down to about 1000 each. We'll see we're getting some sort of cellular type noise. If I go to the other side, we're going to get the opposite of that, which looks like this. If I do a subtraction of the two distances, we get what is commonly known as Voronoi noise. If we want to have something a bit different than that, I like to do is I do a random, plug into the seed, and I plug it out there like that, and we get something a bit like this, which I tend to prefer, but it is up to you what you want. So I'm going to choose that. But before I do this, I'm going to just decrease this a little bit so we can see it. And what I'm going to do is I'm actually going to noise this up again. I'm going to put down a turbulent noise. I'm going to change the 3D noise, and I'm going to say add. And I'm going to add this noise to the position. Now we can see we're actually noising that up a little bit, which looks kind of cool, in my opinion. So I'm going to use that basically. I'm going to copy this, and I'm just going to jump back out here. Get rid of that. And just to visualize it, I'm going to plug into the color, just so that I can see what's going on. And I am actually going to increase this as well, just because I want to have something to be able to use. And that's actually not going to change over time, which is what I want. I'm going to plug this into here, and I'm going to bind export this out as a custom noise. Custom noise. Then if we go back into our DOP import fields, I play a little bit of this, we're going to see that we're going to get custom noise in here. And if I go to my color node and I say ramp from attribute, I'm going to say custom noise. We're going to see the custom noise basically sticks onto that a little bit, in my opinion, just a little bit nicer than the very harsh anti-aliased noise that you had on there previously. But this is just my opinion. I'm going to be using the other one, but I'm just going to be adding layers to this. So I'm just going to quickly let that simulate for a few frames, like so. You can see it kind of stays here, then it just disperses about here. That's fine. So I'm going to export this out. Before I do that though, so I'm going to just quickly make sure that I've got the right path. So I'm going to say hip sim particle sim, then particle sim. So what this is going to do is inside where the hip file currently is, it's going to make a folder called sim. There already is one. Inside that sim folder, it's going to make a folder called particle sim, and inside that is going to make simulation files. One more thing I'm going to do is I want to figure out which attributes I want to keep and which attributes I want to delete. The reason we're going to delete them before we simulate them out is because it saves a lot of space on our hard drives. If we have, so we've got about 1,000,000 points here. If, for example, I put this up to about, let's go 2,000. Let's go to 200,000 basically. It's not only going to increase the amount of simulation time. I'm also going to go in here. I'm just going to change something in this part here. But if we're going to be simming out, so if we're going to simulate out one particle has to have all these attributes on it. If we just minimize the amount of attributes it has, it's going to take up less space on a hard drive. So before we get into that, I'm going to dive into the particles here. I'm going to go to the source in first input. I'm going to say positive. Actually, I'm going to say forward. I'm actually going to say back maybe. And I'm going to just keep it to match topology for now. Now we can see it doesn't have that sub-stepping that we were seeing where it had like this very odd flow. You can still see some of it, but it's a lot better now. I'm going to keep this to this because if I right click onto this material properties here and I change from particles from points to pixels, we can see what it's actually going to look like in the render. We can see we're still getting that sort of sub-stepping there, which I'm not too thrilled about. So another step that we can take to get rid of this is if this is not working, I'm going to say negative. I say forward because forward does tend to work a little bit better. And I can put the max sub-steps up to 2. This is going to take a lot longer to do, but it will actually look a lot better. And this comes down to artistic choice and time constraints, as well as hardware constraints. So my computer isn't bad. The only thing that's probably missing out of it is a decent graphics card. However, you must keep in mind that you may have a deadline, and what you sacrifice inside the 3D engine, you can actually fix up and repair quite a bit in the compositing side. And you can see we're still getting some quite large sub-steps here. So another method we could do to get rid of this is we can up the sub-steps here. So I'm going to go back. I'm going to turn this down to 1. Keep this the same. We could just say match point velocity, but for now, let's just try with match point velocity. I'm also going to go up to here, and I'm going to say about 2 substeps, please. And we can see some sort of substepping going on here. Well, not substepping, but stepping going on here. So let's increase this by 1. And when we do this, this is going to increase incrementally. So be very careful how many substeps you actually do. I'm actually going to pause the recording here so that you don't have to sit here and watch all this. I'm just going to do this in my own time. So the substepping is getting a lot better to look at here, but it is still rather visible. But we'll fix that later. I'm going to put this back down to 2 because 3 will take a long time to calculate out. I'm going to put it down to 2. Actually, I will just put it down to 1. 1 for now, because we are dealing with a lot of points. And I'm going to maybe just decrease this down by half. Just by half, just for the sake of this render. Now back to here, what I'm going to do is I'm going to lay down both an attribute delete and a group delete. With the group, I'm just going to delete everything, because as far as I know, I don't need any of the groups. So now we've gotten rid of all the groups. And inside of our attribute delete, it's got a lovely little thing here called delete non-selected now, which I'm going to use. So I want to keep the color. I want to keep the velocity. I probably normally want to keep the age, the ID, and the custom noise. I don't need to say delete, keep the position, because by default, you can't actually delete the position. I think I will just delete the age though. Oh no, I'll keep the age. If we keep the age and we keep the life, then we have like a normalized age, which you can add, but it's up to you. I'm going to cache this out, and I will be back in a few moments. Okay, so I did one change. I basically turned it down to about 40,000 because my computer is a little bit slow currently. It's copying. I'm making a backup onto some external hard drives, I should say, because my computer is in need of a hard reset. Got some more hard drives in here. And I need to install those. I need to wipe the system, but currently it's going a bit slow. But for now, it's working. So what I'm going to do is I'm going to copy this and jump over to here. I'm going to get rid of that, and I'm just going to enable this. So now I did about 290 frames. That's good enough. That's good enough for a good amount of articles. So now what I want to do is I want to just go through and make sure everything's rendering properly. I'm going to hit stop because it actually is trying to cache out the frames again. And I am just going to now go to here because that is what is going to be rendered. Okay. So now this is all rendering out. This is going to be rendering out properly. I'm not too sure which camera you set it up to be, but we'll try and make one that's relatively alright. And we've got the 2 spotlights that you've got here. I'm going to disable both for now. Just for now. Just as we go through the render engines. So what I'm going to do is I'm just going to render out this render statue here. I'm going to go to the out. I'm going to make a new node. I'm going to call this primary render. I'm then going to figure out which camera I want to render from. Let's see, camera 3, 4. Let's go camera 1. Let's just keep it at camera 1 for now. I'm going to just get rid of that for now, and I'm going to go to the render view here. I'm going to make sure that I'm on primary render, top camera, and I'm just going to go to the OBJ for now. I'm just going to get rid of this, rid of all this, I'm going to keep this in there. I'm going to keep this here just to start out with. And what's going to happen is it's just going to start rendering out as ray tracing. And you're going to see there's going to be some errors. This is just it's trying to render out this asset here. And you can see it's become pink. So what I'm going to do is instead of adding that, I'm just going to go to here. That it is no longer actually going to be looking for a material. It's just going to be render out white for me. So I don't want it to render out anything. And what we've got a few options here. We've got the preview mode and we've got the auto update. Auto update happens is what that means is that if I enable or change a setting, it's going to update automatically for me. Right now, I'm not too happy with the particle size. That is quite a large size for the particles. So what I'm going to do is I'm going to go into here and I'm going to put it down to 0.05, maybe even 0.04. I'm going to hit render. I like my particles really small and really fine. This is the preview we get. And it's kind of obvious that we need a few more particles. What can we do? So I'm just making sure that I'm on pixels still. What can we do? Well, let's go in here into our render statue here for now. I'm just going to turn it onto this. Let's change the color so that it is being ramped by the noise. I'm going to make this a blue and black sort of thing. So it looks kind of nice over here, a little less so over here, but that's fine. I just wanted to add some color. Let's go a bit closer. I want to basically add more particles to this. I'm actually going to hit D, go to background, and change it to dark so I can actually see my particles a lot easier. And you can clearly see the substepping here with the lines coming on there. Okay. So one thing I can do is I can say point replicate. And before I even plug it in, I'm going to turn it down to 5. I'm going to plug this in here. And we're going to see that we've lost our noise. So I'm going to go to a point replicate. I'm going to say copy the source attributes. That's just going to copy over the source attributes for me. And we're going to see it looks quite horrible. So what I want to do is I want to say, hey, keep it to the particle size. But we don't actually have a particle size. Right now it's just, so that means the size is just going to be uniform scale of 1. So this is going to go about a size of meter 1. And if I put in a particle size, then it's going to scale this uniform scale by the multiplied by the particle size. So let's make a particle size quickly. Make a point VOP. Dive into here. I'm going to say bind export. I'm going to call this P scale. And then I'm going to do I'm just going to middle click on here, go from rope parameter, go back up. I'm going to put this to 0.03. Now if we click on point replicate, we should see is a bit of a finer approach. Let's just zoom in on something like this over here. So if I decrease it, we can see it's actually coming into 1 area. So I'm going to push it back to 1. This is how big the particle scale of 0.3 is. I'm going to halve that again. So we're getting a little bit more streamlines here. Maybe even a bit less. So we've got 2.5. And what I'm going to do is I'm going to say velocity scaled. And we're going to increase that by a lot. Only problem with this is that it tends to just increase it by 1 spline over there. So what I like to do is I'm going to turn off the scaling of the particles. And instead of that, so we've got about 41,000 just by duplicating it about 5 times. I'm going to do a time shift. And I'm going to do 2 time shifts here. Turn that off. And I'm going to merge it back in. Time shift, and then merge those back in. And in here, I'm going to click on this so it goes to the actual H script thing. I'm going to say -1, and then this one I'm going to say -2. What this is going to do is it's going to go back. This is going to go back 1 frame. This is going to go back 2 frames. Okay. So we're getting something a bit like that. Doesn't look too great. So let's see if we can try and scale this a little bit. Oh, honestly, it could be this part here is being scaled. No, this isn't being scaled. Okay. Let us try and scale it again. And we may just turn it down to just having 1 time shift here. Okay, it's not really working, is it? There are steps to getting around this and making a nice smoother looking flow. However, it's very code heavy, and I don't want to have you go through that just yet. I'm going to just get rid of one of them. So we're just going to get that. One thing you can do is we can do a trail node instead of doing a time shift. So I'm going to get rid of this merge. And if I go to this trail, we can see we've got a preserve original. And what this is going to do is it's going to do basically the same thing as this did. The only difference is I can actually decrease this about 0.25. And it's a little bit faster as well. So let's go to about 4. So what should happen is we should see a gradual growth from where we had it originally. And we're not really getting that because it is we need to have substeps, and we just don't have substeps on here. So what we can do is we can say time blend, and in here I'm going to say by speed, and I'm going to keep the speed the same, honestly. Or what I could do is I could say collision source, and inside here I just need to say velocity. Don't change this, don't change this, and I'm just going to keep this one on. And then what I can do, plug this in, and now this is going to it's going to use the time blend node. It's just set up with some presets, and it's going to be able to make our trail node actually linearly interpolate between like subframes. And there we go. Now we've got some subframe going. It does look a little weird, I admit, but this is ideally one of the better ways to do it. So I'm going to keep this down to about 2, just so that we don't have to do that many. And now, instead of about, how many points did we have? We had about 8 million. Now we have 8 million times 5, which is 41,000, and then times 2, which is 83,000. 83 million, I'm sorry. Okay. And now, what we're going to do is, so we've got a point scale on here, and what this is going to do is if we go back up to here, it's actually going to affect our point scale on this here. I'm going to put the back to 1, and I'm going to go back to the render view, and I'm going to hit render again. So I already set the point scale to about 0.03, and this is the point. This upper level point scale here is a multiplier of that. So what I should be able to do is, and it's going to take a little while to actually create the render, because of now instead of I think it was 8 million points, we now have a lot more points than that, and you can see that the points are now quite large. So I'm going to put the step to 0.1. And now we're going to be fine tuning this a little bit now, the point scale. So we can still see the points. If we really wanted to, what I can do is I can do an attribute delete here. And I can just delete the P scale. And I can go back up and put this to back to 0.03. which is what I had it at previously. You can see the particles now rendering out nicely. And if you wanted more particles, then you'd increase the particle count. But keep in mind that you could be negatively affecting your overall render. So if I go to my performance, I'm using about half of my memory. So I could ideally increase it. But for now, I'm good. So what I'm going to do is I'm going to stop this. And I'm going to jump out to my out. And instead, go into the rendering part here. I'm going to close this. And instead of using the render engine of ray tracing, which is kind of nice, I'm going to turn it to, I can either turn it to micropolygon rendering or micropolygon physically based rendering. Now PBR is something you've probably heard about, and I do like to go to PBR, but to be able to make a use of the isotropic volumes that we're going to be rendering out, it tends to work a lot better with the micropolygon rendering than the PBR one. And ideally, what we would do is, instead of just creating geometry flag here, is we would render it out into the memory device or an IFD. However, with Houdini Indy, you can't do that. So but that's a small trick that people do use. So what I'm going to do is I'm going to increase the amount of particles. That seems like a silly idea to do, but well, I'm going to do that so that we're going to get a nicer amount of particles. I'm also going to get OBJ here. Point replicate, I'm going to set to 15. And inside, I'll keep it to this now. But what I'm going to do is I'm going to go back out to my OBJ, back to my out. And if I go to objects, we can see we've got a headlight creation. I'm going to turn that off. Actually, I'm going to keep that on for now. With the candid objects, I'm going to turn that off. And I'm going to say force objects. I just want to have the render statue on, which is this one. This should actually be called something else, like a particles. And this is the actual statue that we're going to be rendering. And we can use that as the force matte. Like so. Okay. I'll go into these limits here in a second as well. That's really all I need for now. I'm going to hit render. It's actually going to calculate the point replicate part. And then it's going to go through the trail node. And if we look at my memory, we can see the memory is starting to peak up. 70, 71. Now it sends it all to the render engine. What it's done is it's basically loaded it up into the memory. As you can see here, it's still loading into the memory. Hopefully it will be done soon, loading into the memory, because it is nice. So this is why sometimes if you render it on a GPU, it can fail. With GPU render engines, this is why it can be so difficult to create them, because you need to load massive amounts of data to the GPU, which is why you hear something like data streaming, is where it just reads directly off the disk. It doesn't have to load it into the memory of the GPU. That really does help. So we can see it is actually rendering out here. And I probably should have turned it onto this. Now we're going to get to see what the particles are looking like a little bit. There's a lot more of them basically, and you can really see the subsets here, which is why I would increase the subsets on the DOP network and increase the particle count as well, so I don't have to do this point replicate. But okay, so let's stop that for now. I'm going to go back and I'm just going to cut out a lot of that. So I'm going to go back to this statue here. I'm going to turn off this trail and I'm going to just set this back to about maybe 4 instead. I'm also going to set it to this section here because I want to start doing the actual shading. Let's turn this off. Let's go back out to the out. Let's turn off headlight creation. Let's jump back up and let's create a spotlight in basically the same position as this one, because I am lazy. So I'm just going to duplicate this one. I'm going to color it red. Hit enable, and so we've got 2 spotlights here. We've got 1 and 2, basically. One's more of a fill light. The other one should be more of a retro, a depth one. They're both depth placed. And what we're going to do is, oops, go back to here, got enabled, and we want to make sure, first of all, what I'm going to do is I'm going to make a new material. Go into the material network, and I'm going to go material builder, and in here I'm just going to call it volume ISO again. Up inside, take these away. I'm going to say compute lighting, and then lighting model. And I'm going to keep these as the same for now. I'm going to plug this into the BSDF here, and the color into the CE. I don't know why these are different, why they're swapped around like that. It is quite annoying, honestly. Plug these into here, here, and I'm just going to keep it like that for now. I'm going to go into the lighting model. I'm going to say isotropic volume. Go back into the render view and click render. And let's try and make sure we're getting our depth, basically. And I'd like to get rid of this. I forgot to actually add the material. Let's go back up to the material. And let's hit render again. And the only problem here is that we don't really get to see a depth shadow, which isn't very nice. So let's just increase this to about 0.5 to what it was originally, which is again quite large. But this way we'll be able to see our depth shadow, which we can. And you'll notice that if I increase that, then what's going to happen is the depth shadow is quite harsh. So what I'm going to do is I'm just going to get rid of both of that, get rid of that one, and I'm just going to enable both of these. And Saber's already gone through the depth shadows with you, so I'm not going to repeat myself. So let's just wait for the depth shadows to be created. So there are some times when the depth shadows don't get generated and you get errors. There's not really a great deal you can do. What you can do is you can set the paths where the depth shadows are going to be made. But that's about it. So there we go. There's our depth shadows. I tend to give one of the spotlights a bit of a bluish tint. So let's just see where the spotlights are. So that's this fill one, that's this one. So let's make this one be a bit on the bluish side. Make this one a little bit on the reddish side. Make this one maybe a bit more blue. A bit too blue. Okay. And the intensity and exposure are they're kind of linked, but they're kind of also not. It is a grey area, unfortunately. It is quite hard to get them right. Basically, the intensity is just basically how intense. The exposure is how much light is being let into the camera itself. Basically, that's how I see it. That there are better people who can explain it more coherently. As you can see, we're currently just getting one light. We're not getting this light at all. So let's increase the intensity. I'm not even seeing it. Right, let's just turn this. Let's disable this. Turn this back on. Oh, there we go. It's basically like a fill. I'm gonna put this back to about 1. This to about. You can see that the 1 basically we're getting a color back. Exposure it's just basically how bright it's going to be. If I turn this down to 0, if I turn the intensity up, we're going to see that we're not going to lose as much color as fast. I'm going to turn the exposure up by a little bit to turn this intensity down though. So then I'm going to stay enabled again. So we're going to get something a bit like that. Let's turn the exposure down. Turn this up a little bit. At 1. And you can see it is a bit harsh. So let's see if we can put a smaller roll off both of those. Not really, because it's basically what's happening here is the attenuation. That's why it's a little harsher. And we tend to have like a ramp multiplier here to help blend it. You'd also tend to want to have the shadow not be 1-to-1 basically on both of them. So you'd have like a bit more of a blur on basically maybe this one here. Like so. And we can basically turn these off and turn these on. So I'm going to turn these both off. Lights, attenuation thing here. And I'm just going to basically match these a little bit. Just increase the blur as well. And then I'm going to stop and hit re-render so that it's going to refresh depth and it is going to refresh the depth map shadows. And we're not seeing any details here, which I'm a little bit disappointed about. That's fine. Okay. I'm going to jump back into here. I'm going to say 15 again, and I'm going to turn this down to 0.01, sorry. And I'm going to hit re-render, and now it's going to take a little bit of time to render now. But now what we're going to do is we're going to fine tune the color of our material. So, I don't have Photoshop installed anymore. Do I have Paint? I have Paint, cool. So when we have vectors, we have a few different types of way of doing it. They are all displayed the same in data view, but we have a few different types of speaking of them. In Houdini, though, we just call them vectors. Okay, that's really, really small. We just call them vectors. So let's say these are points here around like that. Okay. Now, these all have a position vector. So this is, so if we go like this, so this is the y. It's not a y, is it? This is the y. This is the x. 0 here and here. So this is like 1, 1, 1 and 0.5 maybe, sort of thing. This one's like 3 and 0.5 still. 3. So 7 now. Sorry. 3 and like a 0.5 here. And this is like a 2.5 by a, well, actually the x would be first, sorry. The x will be first and the y will be next. That's my bad there. And these are what we call points because they are a positional value. When we talk about vectors, they are normally a directional one. So if I was saying at this point here, the direction of this point from this point to this point is that much. And what we have here is it is if we say this, if we say 0 by 0, take away this point, what's going to happen is it's going to move this point. Basically, in maths, it's going to move this down to here. So we're going to get a position, a direction going that way. Or it could be going that way. Honestly, I can't remember which way it's going. And that's just the way, that's how we can get like an angle sort of thing. So this is going to be another position, there's going to be another position here, going to be another position here. And you're going to notice that they're all different lengths. And it doesn't matter if it's down here, sort of thing, or if it's over here. You're going to notice that they're all different lengths. And what this implies is that if we measure the length between 0 and here, or an arbitrary value, we just measure the length of that, then we can get the speed. So if I have a point here, and the vector is pointing out this way, basically in the x and y, the z value also comes into it, but for now we're just going to deal with x and y, and it's pointing out a very harsh way, sort of thing. If we take the length of that vector there, that is going to be our speed. Now the speed can go from 0 to millions, basically. But if we want to color our speed, we have to convert it into a numerical value that we as humans can see, because we can't exactly see once you get past a certain Kelvin or a certain brightness, we're just going to see white. It doesn't matter. So this is 255 by 255 by 255. If I was on a 8-bit monitor, I'm not sure. I'm pretty sure I'm on a 32-bit monitor. I'm not too sure. Honestly, monitors don't really come into my world. But basically, once with our monitors, we can only see up to a certain range, which is why we have something called levels and curves, because then we can actually see the values of those ranges and we can adjust them so that we know that on a better screen they actually fit. This is delving into different topics that are outside the realm here, but this is just a small glimpse into it. So what that means is that if we've got a minimum, so let's say one particle is barely moving, it's going like 0.2 meters per second, incredibly slow. And then we've got another particle next beside it, which is going in the same frame. It's going a few light years, which is being a measurement. It should be a measure of distance, but whatever. We want to be able to see both of those from a 0 to 1 basis. So if we say 0 is black and 1 is pure white, then that's what we can see. Other values from 0 to 255 It depends on what color wheel you're using, what program you're using. So Houdini can do both. It tends to be 0 to 1 or 0 to 255. When we're dealing with particles and attributes and points and being able to visualize stuff on the screen, we'd like to deal with 0 to 1. So I'm going to go here, and I'm just going to change this light just to be a little bit less harsh on the color part of it. I'm going to hit stop, and I'm going to go to here, inside here, and I'm going to start by making a color. So if we bind in our velocity, which is a vector, so we've got free floats, vector, and vector, and we've got normal, we've got point. Don't worry about those. These are just basically Houdini has to have these definitions. We just tend to say vector for everything that is a free valued item. So a position is a vector, a normal is a vector, a velocity is a vector, a UV is a vector for some reason. It doesn't have a Y value, but it is a vector. So we're going to say vector for now. And if I plug that right in, we're just going to get a color. So let's just plug that into the fuse, and let's take a look at what the raw velocity actually looks like. And that's our raw velocity. Now the reason it's mainly blue is because it's going to one side. If, however, I change it to P, which is our position, well, for starters, it's not actually going to work. I need to refresh it, or I need to stop it and then re-render it, which is annoying. So I'm going to actually hit stop, cancel, escape, and it's all frozen. And what I'm going to do is I'm just going to jump out, and I'm just going to go to my OBJ, to my render volume here. I'm going to put that down to about 3. So we have less points to deal with, so we can run a bit faster. But you can see it's airing out. Plea is already used. So let's just turn that off. Where is it already used? It's in the surface globals here under P. Let's take a position, plug it in here. I'm going to put this back to V. And that's a position. So if we were to look over on the other side, it's actually going to be completely black because it's going in the negative X, Y, and Z component completely. But over here, it's completely blue because so the X and the Y are basically zeroed or close to 0, but the other one, Z, is now is basically complete 1. And it's just clamping it. So let's disable that. Plug this back in to use. Let's get the speed. So the way we can do that is we can calculate the length of it. You can see it basically just turns it all to full and white. But I want to be able to make sure that, so the speed, as we said before, can go from 0 to 1,000,000, basically. I want to make sure it goes from 0 to 1. So I'm going to do what is called a fit range, where I'm going to take 0 to 100, basically, as an example, and I'm going to remap that down so that when the value is about 50, it's going to be 0.5. When it's going to be 100, it's going to be fully 1. What I'm going to do is I'm going to do a fit range for now. I'm going to leave that to the one side, and then I'm going to put down a ramp parameter. Well, I'm going to keep it over here. I'm going to jump up. I really do hate why you have to jump up out of this here. I'm going to set this to completely red. I'm going to set this one to blue. I'm going to make one in the very middle, and I'm going to set this to green. This is just a way I can visualize to make sure that I am getting all the values. So I should ideally, if the values are going from 0 to 1, I should ideally get I should be able to see all these colors in here. And we're getting some very slow values and some very fast middle values and fast values. But I'm not too sure. It's not quite a nice faded gradient sort of thing. I want to make it a bit more faded. So I'm going to plug in this fit range here. And I'm going to say, hey, if it's from 0 to 10, then go to it. Now you can see it's pushed it more to the left. So we're a bit slow here. So let's push it back to 3 maybe. Make it maybe to 2. And now we're going to see we're going to get a little bit nicer values there. So that we're getting a bit more faded there. We can even fit this to 0.2 almost. That if it's slower than 0.2, or we can go say negative 0.5, which is not actually going to come up because nothing is in the negative. Nothing should be moving in the negative because we're calculating the length of a vector. So we don't need to do that. And now we're going to get all the values from there to there. So about 0 to 2. What we can then do is, if we want to check, if I wanted to check out what the values were, what I can do is I'm going to go into here and I'm going to say, before I even do this collision value, because this collision source could actually be doing something to my velocity, what I'm going to do is to visualize it. I'm going to say attribute wrangle. So I'm just going to quickly do this in a wrangle because I want to see it. So I'm going to say at CD equals the length of my attribute V. And if we go into my geometry spreadsheet, go into here, you can see there's some is like free, some are at free. What I want to do, instead of just putting it into there, I'm going to put it into a float. So I'm going to say the speed is into the length. And if I wanted to get the maximum value, I can say attribute promote. Inside here, I'm going to change it from, I'm going to keep the point, and it's going to be speed. And I'm going to change from point to detail. And in my promotion method, I'm going to say the maximum value that you can find. Go to my detail, we're going to see it's about 3.7 is the fastest that's going to be there. Let's go back. So let's go jump back up to my material. I'm going to keep it to about 3.5. And now if I hit render, I know that I'm getting all the values there. I'm not basically making one value brighter than the other. What that does mean though, however, is that some values are going to be a bit skewed. So another thing we can do is we can remap it by another ramp. And the way we're going to do that is I'm going to say ramp parameter. I'm going to change this to ramp 2. I'm going to change this to a spline ramp. It's going to start erroring out because it doesn't know what's going to happen. Doesn't know what's happening here. Oh dear. Don't tell me it's done. Back up here. So I'm going to change this back to what it was. So that's 5. I'm going to make another ramp parameter. Let's ramp 2. Make this a spline ramp. I don't know why it doesn't like adding a spline ramp to it. That is very unusual. Come on. Parameter name ramp matches the second one, so ramp and ramp 2, so ramp 3. Let's make this ramp 3 and ramp 2. And now we should see one here. I have to redo this again. That's the problem. So whenever you make a ramp, change its default name, because then you'll just run into lots of issues if you don't. If you want to add another one down the line. So I'm going to jump into here. I'm going to plug this one in here. And you'll notice that this one is a float ramp. So the ramp, the color ramp basically. So this is the color ramp. This is the spline ramp, which is basically just going to output a float. And the float is going to be 0 to 1. Doesn't matter what I do. I can't change that. I mean, I can if I push this value to about 15. But I don't want to. What this means, though, is that I can now adjust how much, or basically do like a, as I said before, we have like levels and we have curves in like Photoshop and After Effects, stuff like that. This is what I'm doing in here. I'm actually making a curves attribute. So I'm going to go into here. I'm going to change this to, I like B-spline. And you'll see why later, when I actually hit render and actually start messing with the values. So what Photoshop or the Adobe one has is they have something called a Bezier curve, which they've got an implementation for an infinite Bezier curve, if that makes any sense to you. Houdini doesn't. That's fine, we don't need it. I'm going to adjust this. You can see I can make it very skewed towards one side. And I'm actually going to make it so we barely see. I want a bit of red. I want a bit of red about there. Okay. So now what we can do is we can now adjust these values. I want to make this a nice blue. I'm going to swap these around now, honestly. And I'm going to have like this one to be a little bit of a white. A bit more of a white on it. So it looks a bit like a wave. I do like waves. If that wasn't a bit obvious. So we're going to see like a very dark blue here on this side. We're going to see a nice, where it's fastest, it's going to be a bit of white, about where this blue was here. And the blue is going to be where the green is, essentially. Now we're getting something like that. If we wanted to, we could actually adjust this a little bit. So I'm going to add a point here and a point here. And at this point, I'm actually going to adjust it quite wildly. Maybe not too wild. I'm going to do the same here. We want to have that a bit lighter. Something like that. And that's what that should ideally do, is give us a bit of variation in there. You can see we're not really getting a lot of white. So if we wanted to adjust that, we just need to come into here. But honestly, this isn't exactly white, so let's make it a bit more white. And what I'm going to do is I'm going to push this a bit like that, push this a bit like that here, so that we get a bit more of the blue instead of the purple. Or we could just make another one here, and we could just say, yes, make this one a bit of a light like that. And then this one's going to be another blue around there. So we're going to get a bit of splash of blue, a bit of splash of purple, and stuff like that. And we can start layering this up quite drastically. Add a little bit of green. Well, not really. Oh, just a little bit of green. Okay. Something like that. And then we can even make different changes in spikes here, like so. We get something like this. And we can really drastically change the way it'll basically look. Let's see, we're getting some white here. If I wanted to add a bit more white, then I would just come into here and I would just change the fit range to about 3. And now we're going to get the white, the fully white there. Even though it's going to about 3.7, I'm going to clamp it a little bit. Okay. One last thing I'd like to do is I want to layer on the additional noise that we had previously. So what I'm going to do is I'm going to say multiplier. And I'm going to do another bind. And this one was called a custom noise, I believe. Custom noise. So, and you can see it's not exactly, it is changing a little bit here. But what we can do with this custom noise is if I take it out, I can actually make this drive up opacity. And then we can even run this through another ramp. So if I make another ramp here, like so, and you can see it actually starting to change it like this. So I'm going to say 1, 2, 3. And it's actually mucked up on the other ramps. So I'm going to go back. Just going to change it like that. Ramp 2, ramp 3, which is really annoying how it does this. It is very annoying. So I'm going to say ramp parameter here. I'm going to call this ramp noise ramp. I'm just going to change the name completely. Copy, and let's see if we can paste it in here. Yes, we can. No, we cannot. It's mucked up my noise completely. It's just mucked that up completely. That's great. I didn't mind. I'm actually very annoyed about that. Paste further into here, into the noise. Changes from that to a spline. Change this to the custom noise. And I think it was something like, I had it on B-spline. I know that much. And I'm just gonna keep. I'm just going to get rid of this. I'm just going to plug it back into the opacity here, so I can get this back. So I think it was something like that. So I can't remember it honestly, but I hope that that was basically what it looked like. Something similar to that. So let's just hit render again. Let's take a look. That's not really what I wanted. Let's move this across a little bit. Change this down. A little bit like that. No, I want it. I want to grab a bit more the nicer colors here, like so. Okay, that's fine. I'm not gonna touch that again. I'm going to jump into here and I'm going to attach this to there. And it's fine, even though this takes a vector, if I put a float in, it's just going to read it the same. Okay, made it nice and bright. Let's like this. So the brighter it is around the noisy areas, basically. I'm going to adjust this so that it's a bit like this. And we can even multiply this by the speed if we wanted it to. So I can multiply this by our speed of our ramp here. A second ramp at least. I can multiply it. So plug this in here. Plug this into here. Now we're going to get something a bit like that. And I'm going to say clamp. Because I don't want it to go in between anything else. So 0.5 and let's say 0.2 and 1. Say 0.4 because I actually do want to see some of these colors. Okay. And what I'm going to do is I'm actually just going to pull this down, pull this up here, this down, up, like so. Okay. So, let's jump back out into the OBJ network here. Let's go to U. Turn point replicate back to maybe 20. And let's see what that looks like. There we go. It's quite filled though. So what I'm going to do is I'm going to jump back up and I'm actually going to change this down to 0.04 maybe. That it gets a bit of a finer view. And I'm going to go to the out and we're going to start changing a few the settings here. Let's change to 6 and 6. And I'm going to change my limits from that to 2 and the volume limits to 2 as well. What this is going to do, so you can see we've got the reflect and refract. What this is doing is enabling OpenGL. It's enabling global illumination. Sorry. Turn that on. Now, honestly, we probably don't need we don't tend to need global illumination for a lot of things, and it does slow down our renders quite a bit. So be very careful about it. And it may not even make a difference to our particles here. So you'll see. Okay, there we go. You can see it's a lot slower now because I have actually turned the sampling up quite a bit, but the limits could also be affecting it as well. So I'm going to do 2 renders. I'm going to pause the video. I'm going to do 2 renders with the global illumination off and then on. Okay, see you in a minute. So there were a few errors that were coming up, and what I'd like to show you is that the reason that they were coming up is because of these. Is trying to create VGO, or it's trying to create a deep shadow pass, and it's failing. So what we'll need to do is basically, I'm going to turn this back off. I'm going to turn this back off and turn this off too. What I need to do is I'm going to go out to my OBJ here, and let's actually make a path for our depth passes. So I'm going to go into here, and you can see we've got a temp os.rat sort of thing. And so what I'm going to do is, instead of temp, I'm going to say $hip. Now it is going to go into like that. So instead of that, I'm also going to say temp and then os.rat. And now they're going to actually copy that to here as well. And now what should happen is that it should now generate the map for us. So there was a little error that was coming up, so it wasn't rendering. So let's jump back out and let's hit render to mplay. It is taking quite a long time because it's when I do render to mplay, what that does is it's going to open up a separate, not Houdini, it's going to actually open up Mantra, the exe at least, and it's going to start rendering from there. And we tend to be able to see like little errors like this. So I'm able to create this under where I've actually opened it. So failed to create file, no such file or directory. So we actually need to make the actual file directory here. So let's go back up. I'm going to go into here to particle sim, and I'm going to create a folder called temp. And so now I hit render to mplay. Now what should happen is this is still looking for a connection. What should happen is this should now send it across. And we should see something like that. So that's now disappeared. So it is actually starting to render. If I go to Task Manager, we can see that we've got Mantra is trying to be run. mplay is still listening. So we can tell it's still listening because it's if I hit to disconnect, it would just stop listening basically for a render engine. So hopefully what should happen is this should now boot up, load all the resources that we want, and create the proper files. That was an issue that I've noticed with with rendering depth pass stuff like this. And another idea is that we also want to make sure that you're changing every frame as well. So where I had the hip, I can actually go to it. So if I go to the hip sort of thing, we've got os.rat. We'd actually also say dot the little $sign and F4 there as well, so that it would change every frame, and we wouldn't be mocking anything up. And we can see it actually is starting to render out. It was creating the geometry just then, which the particles is building the octree, which is that's a little hard to get into, honestly. It's basically how renders manage and work, manage the resources to be able to render. But now what should happen is it should now be able to render out properly, and we should see an image come up. That was just a little side detour that I had to make because I was hoping that side effects would have fixed this issue, but it seems like it hasn't yet been fixed. This is something that I've noticed in 18 and 18.5. I didn't notice in 17 or 17.5 or earlier versions. So it could just be a new bug. It does tend to be Windows based, mainly due to writing writes. So you've got to make sure that you're able to still write to the temporary directory when rendering something like this. Otherwise, you're going to get some very weird issues. I'm going to pause this again and let it render. Okay, so it seems like it's going to take like at least an hour to render. My computer's pretty slow currently because it's got a lot of stuff it's trying to do. But we at least know what it kind of looks like. This is what it basically looks like. I've turned off open color. That's what it looks like with open color. That's what it looks like without. This is what you would be getting, I believe, if you didn't have the Asus installed. But I'm gonna go back and turn it back on because Asus. But basically, it just makes sure that nothing is blown out to a great degree. Which is why it kind of does this lovely little ramp on it. Which is what I like, and what a lot of people in the industry still, well, a lot of people in the industry do use when they render out something. This is not going to go anywhere. Fortunately, I'm just going to kill it, and that's basically it for what I wanted to do, what I wanted to show, tips and tricks. So keep this to maybe about 0.02, honestly. Render out more particles. If you can't simulate them out, or it takes too long to simulate it out, do these steps here. Maybe even do this step. Might not be recommended, honestly. But that's basically it. Hopefully the audio was alright for you, and that it was coherent. Please let me know if you have any further questions. I'm going to be resetting my computer tonight, so I may not be able to field them. In that case, talk to Francis. I'm calling you out, Francis. Okay, thank you, and good night.